Okay, so here we go. This is 1.1, measuring segments and angles, and we are going to use definitions and theorems about lines and angles to solve problems and to justify relationships in geometric figures. So we'll talk about vocabulary tomorrow. You need to be writing these things down and know these because you'll have a vocab test. So if I don't mention it, make sure you ask me about it. Let's see, this one we're gonna do in class. Okay. How are properties of segments and angles used to determine their measures? So the first thing we need to talk about is undefined terms. Undefined terms are terms whose meanings are accepted without formal definition. For instance, a point. A point is a location and has no size. And that really isn't much of a definition, but we kind of just accept it. And then we have a line is an infinite number of points on a straight path that extends in two opposite directions with no end and has no thickness. And then a plane is our third undefined term. It is an infinite number of points and lines on a flat surface that extends without end and has no thickness. It's like the wall. It would be a plane if it kept going forever and ever and ever. And you can see the notations over here, how you notate them, and a diagram of what they are. These are the only three undefined terms. These three undefined terms is what we use to define all the other geometries. So, a segment is the part of a line, see we're using that undefined term, that consists of 2 points called endpoints and all the points in between them. A ray is the part of a line that consists of one endpoint and all the lines of the points on the line on one side of the endpoint. Opposite rays are rays with the same endpoint, see right here, same endpoint, that lie on the same line. So you have a ray going this way and a ray going that way. And they make a line together, don't they? And then the last one, an angle, is formed by 2 rays. Look, we have one ray here, and we have one ray here. Each ray is the side of an angle, and the common end point is the vertex of that angle. Okay, so how can you find the length of CD? Well, we're just going to count, right? 1, 2, 3. The notation of CD represents the length of CD. To find the length of a segment, count the units of length between the endpoints. Of AC. Well, we just count, right? Whoops. 1, 2, 3, 4. Try it. What is so the length of AC is 4. This ruler postulate, every point on a line can be paired with a unique real number. It's called the coordinate. Distance on a line, you count 1, 2, 3, 4, or you can use the absolute value of the difference. 7 minus 3 is 4. It's really negative 4, but remember I said the other day, distance is always positive. Find the length of a segment. Okay, so what is KL? And I know this is all on here, but KL, 1, 2, 3, 4. KL is 4, and I forgot to mention, a postulate is a statement that is assumed to be true. So a postulate is just common sense, okay? Need to remember that. That's common sense. What is JK? Well, if you look back there and you count, I think you get 7, and KM is 15. That's relatively easy. So then segment addition postulate. All this is saying is that if I add AB to BC, I'm going to get the whole thing, AC. So if AB is 3 and BC is 7, AC must be 10. All right. So let's not look at this. Okay, I need to start making sure I write some of that out. All right, so let's think about this. Collinear points, first off, lie on the same line. That's one of your vocab words. So this says the first thing you should always do is label your picture. So this says GH is 16, and it wants us to find FH. And because we got X's here, I'm going to label that Y. It wants us to find Y. So you got to think about where you can see an equation. Well, 2x plus 2 has to equal 16, right? So if I subtract 2 from both sides and then divide by 2, I get x equals 7. So then if I plug that in here, I get 3 times 7 is 21 minus 1 equals 20. So the whole thing, 20 plus 16 has to be 36. Okay, so I want you to try this one, and I want you to come back and see if you did it right. Okay, so the first thing that you should have done is label your picture, 25. I know that whole thing is 25. So if I add 3n plus 5n minus 7, and I solve it, I get n equals 4. And then I'm just plugging the 4 in to the in for n. Okay. Protractor. And it's just showing you the numbers and how they assign it. If I start here, I'm using these outside numbers. If I started over here, I would be using the inside. Remember, the measure of an angle is denoted with the little m in front of the angle measure. So the first question, AEC. Well, AEC would be AEC, and so that looks like it's 105, doesn't it? And then the other question is BED. So BED looks like it ends here at 130, and B is at 40 in here. What is the angle? 7. So 130 minus 47 equals 83. All right, so angle addition postulate. So this is just saying if point D is in the interior of the big angle, then ABD, I'm going to call that angle 1, plus DBC, I'm going to call that angle 2, equals the whole thing, I'm going to call that angle 3. All right, And I think I'm going to do this one in class. And then, and the next one in class, this one. All right. Reflexive, symmetric, and transitive. So reflexive is like looking in the mirror. When you look out, you see yourself. So it's just saying like x equals x. And it's using these segments and these angles. So, or AB, line segment AB is congruent to line segment AB. Or angle A is congruent to angle A. Symmetric, if you can remember that S, is switch. You're switching sides is the symmetric property. So if x equals 3, then 3 equals x. If AB is congruent to CD, then CD is congruent to AB. You just switch sides. Transitive property is what I like to call the traveling property. And it is, first off, if we just use x in a number, if x equals 3 and 3 equals y, then x equals y. X travels to the end, that's why I call it the traveling property. Or if AB is congruent to line segment CD, and CD is congruent to line segment EF, then AB is congruent to EF. So that's the transitive property. All right, so this says, what is HF? So let's not look at this. Let's just look. All these little lines, we want to know what HF is. So I'm going to put this down here. X, that's what I'm looking for. All these little lines means they're congruent to each other. So here, if this is 11 with two little lines, then this is 11. Okay? Over here, this is 8 with one line. So this is 8 and this is 8. So now I know that x has got to equal 19. So it says here, be sure to read the congruency marks in the diagram carefully, okay? Because that's telling you a lot of information, making it a little bit easier. I'm also going to do this one in class. Then here, just concept summary for you guys, and then this last is in class 2. Hopefully I haven't left too much for class, but that's it. We'll see you Monday.